This video is about writing linear equations. So you've learned about graphing lines. Now we want to be able to write the equation of a line given some of its characteristics. So the first form that we're going to use to write the equation of a line is called point-slope form. The formula is written on this slide: y minus y1 equals m times x minus x1. What's important to note is that the three variables we're actually going to replace here are m, which is the slope, and we're going to replace x1 and y1 in this formula with a number for each of them that comes from any point on the line. So x1 and y1 could be any point that's given to you that lies on this line. The actual letter x and letter y without any subscript continue to stay the variables x and y. So you need to have the variables x and y in the equation of your line, because the equation is showing you the relationship between x and y. How do you get from an x to a y, right? Input and output. So we want to keep our x and our y alone, and then replace m, replace x1, replace y1. So this example is really simple. Write an equation of the line with the slope -2. So slope is given to us. That goes through this point. That's an x1 and a y1 that's given to us. So all we have to do is follow the formula. Y minus y1, I'll write the formula here a little bit bigger, equals m times x minus x1. Replacing this y1 with -1 is going to give us minus -1, or plus 1, if we want to simplify it. M is going to get replaced with the -2, that's the slope. X stays as x, and then x1 gets replaced with this number 3. And then we stop, right? It doesn't tell us what form to use, so we're going to stop with point-slope form and leave it at that. And I hope that the name of this form makes sense. It's called point-slope form because what were the two things that we replaced in the equation? We replaced a point, x1 and y1, and we replaced m, which is the slope. So point-slope form. The next most common form is called slope-intercept form. And the formula for that is much shorter. Y equals mx plus b. M continues to stand for the slope. This time, b comes from a very specific point on the line. It's the y-coordinate of the y-intercept, which is the point, right? The y-intercept is the point where x is 0. So it's sort of like point-slope form, only you don't have to replace any x1 because x is 0 at that point. So you just need to know the y-coordinate of the y-intercept here. For the first example, write an equation of a line with the slope -4. So here again, slope is given to us. That goes through this point. So you'll notice that specifically they're giving you the point 0, 5, which means when x is 0, the y-coordinate is 5. So these are the numbers that we need for slope-intercept form. So we're going to start with y equals mx plus b, leaving y as y, replacing m with the slope that's given and leaving x as x. And then b gets replaced with the y-coordinate of the y-intercept. This is the y-intercept because the x value is 0, and that means b is going to be positive 5. More commonly, you'll use point-slope form from the previous slide and turn it into slope-intercept form. So usually you'll be given a point that's not 0, 5, right? You'll be given some other point. And so you'll want to start with point-slope form, which is the first one that we covered. And then if it's asking you to write it in slope-intercept form, it's a simple algebraic process to convert it from point-slope to slope-intercept. So here, the next example, you're given an equation that's in point-slope form. I can drag it out here and make it a little bit bigger. So we're given this, which is point-slope form. Maybe you recognize it. It's got the y minus y1, and then the m times x minus x1. Asks us to write it in slope-intercept. Slope-intercept, you'll see, has y equals on the left side. It needs to have y by itself. So what we have to do ultimately is move this -4. So we're going to add 4 to the other side. But before we can do that, we need to distribute the 1/2 that's happening on the other side, simplify the right side of the equation. Then we can move over the -4, and it'll be in y equals mx plus b form. So let's start by distributing the 1/2. 1/2 times x, and 1/2 times -5. Now when you multiply a fraction times a whole number, remember the whole number is over 1, so you can do top times the top, -5, and then the bottom times the bottom, over 2. And then we'll leave it as a fraction. Excuse me. Then we're going to add the 4 so that we can have y by itself. On the left, y will be alone. On the right, the 1/2 x stays the same, right? We're not adding 4 to that. And we need to add 4 to the fraction 5 over 2. So for this, we need a common denominator, which means you need to add something over 2. And then we turn 4 into 8 by multiplying that by 2 as well. So adding 4 is the same as adding 8 over 2. So negative 5 over 2 plus 8 over 2 is positive 3 over 2. And that is slope-intercept form, right? It has y equals, it has the n value, and it has the b value. If the step that confused you most was adding that fraction to the other side, or adding 4 and then having to get a common denominator, that's a whole separate thing to review, and we can work on that another time. The third form is called standard form of the equation of a line. And the formula for that is ax plus by plus c. What's important to note is that a, b, and c have to be integers. Integers means whole numbers, positive and negative. And then more specifically, a should be positive. What trips people up the most about standard form is thinking, like, I don't know what is a, what is b, and what is c. I don't know what they are. Are they the intercept? Are they the slope? Like, where's the slope in this equation? But it's important to note a, b, and c are not any of those things. A, b, and c are not characteristics of the line that you're going to be given in the question. The only way to get to standard form, and I'm going to write this because it's actually such an important note. The only way to write an equation in standard form is to start from slope-intercept and rearrange it. What does that mean? So if I give you some characteristics of a line and I ask you to write the equation in standard form, you need to start by writing the equation in slope-intercept form. That's what we just practiced on the previous couple slides. So you're going to start by writing it in slope-intercept form. And once you have it in slope-intercept form, rearrange it to the proper order to put it into standard form. So standard form is just a rearranged version of slope-intercept form. That's how I want you to think about it. So in the example where I left some space up here, the given equation is in slope-intercept form, or maybe you came along and you got that equation in slope-intercept form, and now we're rearranging it to be in standard form. So to rearrange this equation to be in standard form, we need our x term to be first. So look at standard form, right? It has ax first, which just means some number with x has to come first in the equation. So I'm going to subtract the 1/2 x so that it's in front, which means we'll have negative 1/2 x plus y equals negative 4. And then it's in the correct order. It has the x term followed by the y term, followed by the equal sign, and then a constant. But none of these numbers are right because it says that a, b, and c have to be integers, which means I can't have this 1/2 in my standard form equation. Moreover, a is supposed to be positive, and here it's negative. So in order to deal with the a value, make it both positive and a whole number, I need to multiply the entire equation by the denominator of the first fraction, and I'm going to multiply it by negative at the same time to make it become positive. I'm allowed to do this as long as I do it to the left side and the right side of the equation to keep it balanced. So negative 2 times negative 1/2 is going to end up just being positive 1, which changes the coefficient of y to minus 2y, and it changes the c value on the other side of the equal sign to be a positive 8. This is the standard form version of this linear equation. So I started with slope-intercept form, rearranged it, and made everything be an integer, and made a be positive. Now I have the standard form version of the equation of this line. To go from start to finish through all three forms, you may be given the slope of a line and a point on the line. And it asks us to write the equation of the line in point slope, then slope intercept, then standard form. So this is the easiest order to do it in. It's always the order I'm going to ask you to do it in. For point slope form, all you need is a point, which we have, x1, y1, and you need a slope, which we have over here. So it's going to say y minus y1 equals m times x minus x1, and you stop. Nothing more than substitution. Then slope-intercept form involves getting y by itself, but in order to add the 2 to the other side, this 2 right here, I need to distribute first. I'm going to distribute on the right, so it'll say negative 1/3 x, and then negative 1/3 times 6 is like negative 6 over 3, which is just minus 2. I'm going to add this 2. Y is by itself. Negative 1/3 x isn't changed. And negative 2 plus 2 is like 0, so I don't need to show a plus 0 as my b value. So my slope-intercept form here is pretty short. And then to put this thing in standard form, I need to take my most recent answer, my slope-intercept, and rearrange it. So I want my x term, this whole term, to come at the beginning. So I'm going to add it. So it'll say positive 1/3 x plus y equals, well, our b value was 0, so I need to show something over there. And of course, the only issue is that I can't have fractions in standard form. So I'm going to distribute the denominator, which is 3, through this entire equation. So 3 times 1/3 becomes x. The coefficient of y becomes 3y. And 3 times 0 is still 0. So my c value is going to stay at 0. And that's the standard form version of this equation. Slightly more complicated, only in the first step, is this one. So given a line that goes through these 2 points. Now, I have an x1 and a y1, but what I'm missing here is the slope. In fact, I have a whole nother point as well, which we could think about as x2, y2. But in order to write the equation in any of these forms, I need the slope. So the first thing you want to do is calculate your slope. And you should recognize the slope formula, y2 minus y1 over x2 minus x1. That's something we've practiced before. So y2 minus y1 is going to be 2 minus 4 over x2 minus x1 is negative 1 minus negative 5, which is plus 5. So negative 2 over positive 4, which simplifies to negative 1/2. Always simplify your slope. Now we have an m and we have a point. So let's write it in point slope form. Whoops. Y minus y1 equals m, which we calculated, times x minus negative 5, which will become plus 5. So there's point slope. To get into slope-intercept, we need to start by distributing the right side in order to add the 4 to it. And adding 4 is like adding 8 over 2. Recognize these numbers. Okay, there is my slope-intercept form. And to get it into standard form, I'm going to rearrange it. So I'm going to move my x term to be at the beginning by adding it to the front of the equation. Then it'll say plus y. It'll say equals 3 over 2. And I need to deal with all of these fractions by multiplying by the denominator. So x plus coefficient of y becomes 2. And then 3/2 times 2 is just 3. So then everything is in order and has whole number coefficients. And that is all.